We are going to continue with implicit functions in this video. Another question, y is equal to root of log x plus root of log x plus root of log x plus etc. to infinity. So this is similar to the questions which we discussed in the last video. So this expression goes to infinity. So root of log x plus root of log x plus root of log x plus root of log x to infinity. So what I'm going to do is I will again consider the same way. I'll say y is equal to root of log x plus. Look at the rest of the expression. I have highlighted that. If you try to read that, that's root of log x plus 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 etc., which is the same as my question. Although I have already written one root of log x, the rest of it, since it goes to infinity, doesn't make any difference. It is still the same as my question, which is y. So I can replace this entire remaining expression with y. So my question is going to look like y is equal to root of log x plus y. Then we say squaring both sides. So squaring both sides, y will become y squared, and on the right side the square root will go away, which will give me log x plus y. So I get y squared is equal to log x plus y. And then I try to differentiate this. So differentiating with respect to x, on the left side this is y square. How do we differentiate y square? If it was x square, it would have been 2x. If it is f of x the whole square, it is 2 times f of x into f dash of x. So y square would be 2y into dy by dx. So equal to log x is 1 by x plus y becomes dy by dx. Now there are two dy by dx terms, so I am going to group them on the left side. So I get dy by dx into 2y minus 1, because it is minus dy by dx on the left side. So dy by dx is common. So dy by dx into 2y minus 1 is equal to 1 by x. And that's exactly what we are asked to prove. They did not ask you to find out dy by dx. If the question was to find dy by dx, I would have shifted 2y minus 1 also to the other side. Now you have a question for you to try. Y is equal to root of tan x plus root of tan x plus root of tan x to infinity. Show that dy by dx is equal to sec square x divided by 2y minus 1. So you're going to do the same thing. You will say y is equal to root of tan x plus the rest of it is still y. So it will be y is equal to root of tan x plus y. Then you say squaring both sides, and you should be able to complete it yourself. So pause the video, do this question before you proceed to the next one. Look at this question. This is an important question. If x into root of 1 plus y into root of 1 plus x is 0, with that condition given there, prove that dy by dx is equal to minus 1 by 1 plus x square. Let's try to analyze this situation. This is actually an implicit function. It is under implicit function because y is not explicitly written in terms of x. X and y are mixed into an equation here. So this is implicit. And as we have discussed earlier, any implicit function, when I differentiate, I am supposed to get the answer in terms of x and y. So since the question is mixed in x and y, the answer should be mixed in x and y. But look at this answer given to you. It says dy by dx is equal to minus 1 by 1 plus x square. So the derivative is only in terms of x, while my question is in terms of x and y. That's not going to happen. If the question is in terms of x and y, the answer will also appear in terms of x and y. So that means I should not start this question as an implicit function. I need to explicitly express y in terms of x. My question has to be only in x. That's when I get my derivative only in x. So I'm going to try and solve for x. So I'm going to copy the question. X into root of 1 plus y into root of 1 plus x is equal to 0. I'll shift this one of these terms to the right side. Then I'll square on both sides. So x into root of 1 plus y is equal to minus y into root of 1 plus x. Then he says squaring both sides. If you square on both sides, this will be x will become x squared, root of 1 plus y will become just 1 plus y. On the right side, minus y will become y squared, into root of 1 plus x will become 1 plus x. Now you open the bracket, multiply it in. So when you open the bracket, x square will multiply both the terms inside. So x square into 1 is x square, plus x square into y, x square y, is equal to y square into 1 is y square, plus y square into x is xy squared. In the next step, what I do is, I'll try to rearrange in such a way that I have got similar kind of terms put together. Like I have x square here and y square here. Bring them together on one side, x square minus y square. And then xy squared minus x squared y. So similar kind of terms are put together. X square minus y square is equal to xy squared minus x squared y. But this can be further simplified as this is factorization. X square minus y square is x plus y into x minus y. And on the right side I have xy common, so xy into, if I take xy common out, I have a y balance here minus x. Then I notice something, I have an x minus y here and I have a y minus x there. So what I am planning is, take a minus sign out of y minus x. If I take a minus sign out of y minus x, it would turn out to be x minus y. So that's what I will do in the next step. So x plus y into x minus y is equal to minus xy into x minus y. Y minus x is written as minus of x minus y. You can then cancel x minus y and x minus y from both sides. So you'll have x plus y is equal to minus xy. And then I choose the two terms in y and put them together on the left side. So because I'm trying to find out y, so I keep y on the left side, bring minus xy to the left side. So y plus xy. So the reason for bringing xy to the left side is because we want to solve for y. We want all the terms which involve y to be on the left side. So I keep y on the left side and I also bring minus xy to the left side. So y plus xy. So I have both the terms which involve y on the left side and shift x to the other side, which is minus x. Now y is common factor. So y into 1 plus x is equal to minus x. So I can solve for y. So I'll get y is equal to minus x by 1 plus x. Here I apply quotient rule of differentiation. Therefore, dy by dx is equal to quotient rule. Denominator into 1 plus x into v into 1 plus x into v into u dash, derivative of the numerator. So v into 1 plus x into u dash, derivative of the numerator is minus 1, minus u into numerator into minus x into derivative of the denominator is 1 by square of the denominator, 1 plus x the whole square. Here I'll open the bracket with minus 1, making it minus 1 minus x, and this will become plus x. So it's going to be minus 1 minus x plus x. Plus x minus x cancels and you have your answer. So this was possible. We got an answer only in terms of x because we made our question only in terms of x. You need to redo this and practice it. Here is another question. If cos y is equal to x into cos of a plus y, with cos a not equal to plus or minus 1, prove that dy by dx is equal to cos square a plus y by sin a. Here again I want you to analyze the question first. Look at the question. Is it written as y is equal to f of x? Is it written like y explicitly in terms of x? No. It's x and y mixed up. This is implicit. So we expect our answer to be in terms of both x and y. But what we notice here is that dy by dx is only in terms of y. If dy by dx is only in terms of y, which means my question should be only in terms of y. If my question has to be only in terms of y, that means the question should be written as x is equal to f of y. The question should be only in terms of y. X is equal to f of y. How would I do that? I will keep x here and divide both sides by cos of a plus y. So I'm going to make my question as x is equal to f of y from the question here. So I'll say x is equal to, I shift cos of a plus y to the other side, so it becomes cos y divided by cos of a plus y. Now x is a function of y, and so if I differentiate this, the answer will be only in terms of y. I'm going to say differentiating with respect to x. Derivative of x is 1. And this is quotient rule, u by v rule. So quotient rule is v into u dash, u divided by v, numerator and denominator. So denominator into v into derivative of the numerator u dash minus u into numerator into derivative of the denominator v dash by v square, square of the denominator. So I'm going to start with the denominator. So I'll say denominator into cos of a plus y into derivative of the numerator u dash, v into u dash, v I copied, cos of a plus y into u dash. What's the derivative of cos y? Derivative of cos y is minus sin y into dy by dx, because anything in y when I differentiate is followed by dy by dx. So that is v into u dash minus u cos y into derivative of the denominator v dash. Cos of a plus y derivative is minus sin of a plus y into the inner derivative. A will be 0, so I don't write it, plus y becomes dy by dx. So that is numerator into u into v dash. Derivative of cos of a plus y is minus sin of a plus y into dy by dx. Whole divided by square of the denominator, which is cos square of a plus y. Cos of a plus y becomes cos square of a plus y. Now we cross multiply cos square of a plus y to the other side. So it will be cos square of a plus y is equal to, there is dy by dx common factor in the numerator. So dy by dx into this, here this double minus sign becomes plus y. Write that term first. Sin a plus y cos y, sin of a plus y cos y minus cos of a plus y sin y. But that looks like sin a cos b minus cos a sin b. Sin a cos b minus cos a sin b. And what is sin a cos b minus cos a sin b? That's sin of a minus b. So I'll apply that formula. So dy by dx into sin of a minus b. A plus y minus y, a minus b, a plus y minus y. Plus y minus y cancel, so I have sin a, and I'll shift this sin a to the other side so that I can find dy by dx. Therefore dy by dx is equal to cos square of a plus y divided by sin a, which is what we are looking for. So I have another question here, exactly the same thing. You need to try this exactly the same way. So sin y is equal to x into sin of a plus y. Then prove that dy by dx is equal to sin square of a plus y by sin a. So here again, when you analyze, you will see that your answer is only in terms of y. So my question has to be only in terms of y. That's why I solve for x and then differentiate with respect to x. It's an important question. So take time to do this. If you are unable to do it, you should go back, watch the previous question and try to do this question. We move on to the next question. This is again a very, very important question. Prove that if y is if root of 1 plus x square plus root of 1 minus y square is equal to a into x minus y, then prove that dy by dx is equal to root of 1 minus y square upon 1 minus x square. Now this we don't make an attempt to directly differentiate. You will find it so very difficult to do this. So what we are doing is, it's a very special way of doing it. We make an assumption, we make a substitution into this question. So I'll copy the question first and then I go for a substitution. And the substitution is, I say let x be equal to sin a, choose x as sin a and y as sin b. And we know that the substitution would work because if x is sin a, this is going to be 1 minus sin square a, which has a result cos square a. If y is sine b, this is going to be 1 minus sine square b, which is cos square b, which has a result. Yeah. So we make this substitution into the question. So it's going to look like root of 1 minus sine square a plus root of 1 minus sine square b, because y is sine b, is equal to a into x is sine a minus y is sine b. 1 minus sine square a is cos square a, root of that is cos a. 1 minus sine square b is cos square b, root of that is cos b, is equal to a into sine a minus sine b. Now on both the sides you have got product formula from trigonometry, class 11. So cos a plus cos b is 2 cos a plus b by 2 into cos a minus b by 2. That's the product formula for cos a plus cos b. 2 cos a plus b by 2 into cos a minus b by 2 is equal to a into right side, sin a minus sin b, 2 cos a plus b by 2 into sin a minus b by 2. That's the formula for sin a minus sin b. 2 cos a plus b by 2 into sin a minus b by 2. So this 2 and 2 I can cancel from both sides. I can also cancel cos a plus b by 2 and cos a plus b by 2. So what is left is only cos of a minus b by 2 on the left side and a times sin of a minus b by 2 on the right side. What I am planning to do is bring this sin of a minus b by 2 down here. So it will look like cos of a minus b by 2 divided by sin of a minus b by 2, which is equal to a. But cos theta by sin theta gives me cot theta. So that's going to be cot of a minus b by 2 is equal to a. So I have cot of a minus b by 2 is equal to a, and then I shift cot to the other side. So I'll get a minus b by 2 is equal to cot inverse of a. I'll send this 2 to the other side. So I get a minus b is equal to 2 cot inverse of a. And what is a? Go back and see your substitution. A will be x is equal to sin a v z. So x is equal to sin a v z. Therefore a is sin inverse of x. And we said y is equal to sin b. Therefore b will be sin inverse of y. If x is sin a will be shift sign to the other side. It becomes sin inverse of x. Y is equal to sin b. So what is b? Shift sign to the other side. So sin inverse of y. So I know the values of a and b, which I am going to write here. So this is going to be a will be replaced by sin inverse of x minus b will be replaced by sin inverse of y is equal to 2 cot inverse of a. And then I say differentiating with respect to x. When I differentiate, derivative of sin inverse of x, 1 by root of 1 minus x square. And derivative of sin inverse of y, 1 by root of 1 minus y square. But anything in y when you differentiate, sin inverse of y derivative is 1 by root of 1 minus y square into dy by dx. Anything in y should be followed by dy by dx. Okay, so I forgot to mention this. The derivative of sin inverse of x is 1 by root of 1 minus x square, and derivative of sin inverse of y is 1 by root of 1 minus y square into dy by dx, because it is in terms of y. Now, in fact, this result we haven't discussed, so I will be discussing this result in detail in the next video. So at the moment you are going to accept this result. Sin inverse of x is 1 by root of 1 minus x square. So sin inverse of y is 1 by root of 1 minus y square into dy by dx is equal to 0. For the remaining inverse trigonometric functions, we'll do it in detail in the next video. So remember, since I haven't discussed this result before, sin inverse of x derivative, you go to accept now as 1 by root of 1 minus x square. We'll see the proof later. So now what I have to do is just rearrange and solve for dy by dx. So I leave the dy by dx term on the left side, shift 1 by root of 1 minus x square to the other side. Minus and minus will cancel and you cross multiply, you get this answer. Now I got another question here which is almost similar to the one which we did now. Of course the question has got higher power involved, but you will see that the working is exactly the same going to be. So look at this question. Question is this: y is 1 root of 1 minus x raised to 6, but I rewrite it as x cubed the whole square. root of 1 minus y raised to 6. I rewrite it as 1 minus y cubed the whole square is equal to a into x cubed minus y cubed. So this is 1 minus x cubed square root of 1 minus y cubed square is equal to a into x cubed minus y cubed. So I'm going to choose this time x cubed is equal to sine a and y cubed is equal to sine b, and it works because this is going to be root of 1 minus x cubed is sine a, so it becomes 1 minus sine square a plus root of 1 minus sine square b. So 1 minus sine square a and 1 minus sine square b have got results. So that's the reason why we picked up this particular substitution. So my question now looks like this. 1 minus x cubed is replaced by sine a, so sine square a, plus root of 1 minus y cubed is sine b, so sine square b is equal to a into sine a minus sine b. Now 1 minus sine square a is cos square a, which becomes cos a. 1 minus sine square b is cos square b, and its root is cos b is equal to a into sine a minus sine b. Now cos a plus cos b is 2 cos a plus b by 2 into cos a minus b by 2 is equal to a into sine a minus sine b is 2 cos a plus b by 2 into sine of a minus b by 2. That's a formula which we already discussed. So a and a will, 2 and 2 will cancel. 2 and 2 will cancel from both sides. Cos of a plus b by 2 and cos of a plus b by 2 will cancel. So what is left is cos of a minus b by 2 divided by sine of a minus b by 2 is equal to a, which means cot of a minus b by 2 is equal to a. Therefore, a minus b by 2 will be cot inverse of a. So that's what we have now. I need to replace a and b by its value. What is a going to be? Sine inverse of x cubed, and what is b going to be? Sine inverse of y cubed from our substitution. So our question is going to be sine inverse of x cubed minus sine inverse of y cubed is equal to 2 cot inverse of a. When you try to differentiate this, sine inverse of x cubed, sine inverse of x, we discuss the result as 1 by root of 1 minus x square. So sine inverse of anything, sine inverse of f of x would be 1 by root of 1 minus f of x the whole square into f dash of x. So what's the derivative of sine inverse of x cubed? 1 by root of 1 minus x cubed the whole square, f of x the whole square. X cubed the whole square makes it x raised to 6 into f dash of x. F dash of x, derivative of x cubed is 3x square minus sine inverse of f of x, 1 by root of 1 minus f of x the whole square. So my f of x is y cubed, so it is 1 by root of 1 minus y cubed the whole square, y raised to 6 into f dash of x. What's the derivative of y cubed? Y cubed is 3y square into dy by dx is equal to 0. And from here, we try to solve for dy by dx. So I keep the dy by dx term on the left side, and the other term to the right side. I shift it. Minus 3 will cancel, and you cross multiply. So you get dy by dx is equal to x square into root of 1 minus y raised to 6 by y squared into root of 1 minus x raised to 6. So in this video, we actually used one new result, which is derivative of d by dx of sine inverse of x, which is 1 by root of 1 minus x square, which we hadn't discussed before, but this will be done in detail in the next video for all the trigonometric, 6 trigonometric functions.